Okay, and here we are. Okay, we are back. Okay, so today we are moving on with our study of functions. And last time I think, well, I don't know, we're talking about asymptotes today. I think we've done asymptotes a little bit. Yes, yeah. Anything we've done before the quiz can be on the quiz, so including today. Thank you. I'll never surprise you with new stuff, but there may be extensions of things we've done, but definitely no new topics on a quiz. Like the quiz will be at the end of class next time. Anything we do before class next time isn't a candidate to be on the quiz. That just doesn't seem fair. It seems like you at least need a couple of days to digest the material before being quizzed on it and ask questions. Correct. Although probably what we do next time will reinforce what we're doing today. So that'll be a nice little bonus for the quiz. So a little bit of review in class. Was there another question?
What do you mean extensions?
Extension is it's kind of like optional. It's I'm not requiring you to do them, and it's very often the extensions will go down a rabbit hole. Where do you see this?
Well, you said that on the quiz there could be extension.
Oh, I see. I'm sorry. I see. Like I may have given you the problem. Can you factor this? And then the problem may be something like, can you factor this? Right, just kind of like expanding it. Or instead of a y, maybe we'll have, I don't know, 3y minus 4 cubed in there, or something like that.
Wait, so those are very different.
This is the difference of cubes. And this is a pretty extreme extension, but I'm saying this is not a new. It's an extension of what we've done. Maybe you won't recognize it directly, but break it down.
Solve it.
Uh,
One with the two and another three.
yeah, exactly. Yeah. Your algebra 2 teacher taught you well. Give myself a little praise right there. You worked hard in algebra 2. Giving you praise too. Okay. In any case, let's go on with today's stuff. Good question. Let's talk about asymptotes, shall we? And behavior and asymptotes. Oh, let's go over this. Describe the end behavior of y using limit notation. We didn't do this one in class, but let's see what you did for your assignment. So go ahead and take one to discuss this problem specifically with your partner. Until then, yeah.
You said any x approaches infinity, y and then
Okay, folks, your attention, please. Before I talk about this one, look at please. Okay. So let's get into it. Before we do this, can we please show an end behavior of this y equals x squared? Y equals x squared. What I'm looking for is end behavior of y equals x squared. Negative x squared. X cubed. Looks like you guys understand all the behavior, which I appreciate. The end behavior, I hope it makes sense. It's just this, isn't it? There's stuff going on in the middle. We're just talking about ends, right? As x goes to positive infinity, as x goes to negative infinity. But it does. But when I'm talking about end behavior, I'm talking about two things: x going to infinity or negative infinity, unless the domain is restricted. But you're right, and I imagine, yeah, and domain is restricted. So I imagine this is what you have in your heads, correct? Because this is what I was saying. Oh, it is frozen. Thank you. This is what you have in your heads.
Oh.
Ding. Yes. Does that look like what you have?
Yeah.
When I'm talking about end behavior, all I care about is what's happening here and what's happening here. I don't know, there's stuff going on in the middle. Same thing as, you know, if we're doing this polynomial and I'm asking about the end behavior, all I care about is this. I care about the ends, hence end behavior. I don't care about, oh, there's something weird going on in the middle. Just the end happening on the left side and the right side. So we would say that the limit as x goes to negative infinity of this function is equal to 0. And the limit of this function as x goes to positive infinity is also 0. I hope that's clear. Now, from time to time, you may see some notation that may confuse you if you just like, if you're struck with it. But this would be appropriate, though. I would never ask you to put that little negative on there. And this would be appropriate, though. I would never ask you to put that. I want you to discuss with your neighbor. What do you think this little negative is? So last time we spoke about, oh no, it's here. We talked about these. All right, limits approaching a number from the left and from the right. So did you tie it together with that? This would be it's approaching 0. How would you say it?
From the negative side.
Remember, this is x, right? X approaching some number, right? But this is going to be the y dot, where it's going from the 0, getting to the y dot is here above or below. So this thing broke it from below. From above. So when you see that, don't use it again. I would expect you to use that. And it's unnecessary. Okay, in terms of ends, I know you may feel a little bit empty now. What about this? What about this? Does the leaf feel empty? Just not talking about that? If there's negative and positive, this is the specific behavior around the vertical aspect. We're talking about that. And behavior is only behavior. And like, even though it ends. So F. You have any idea what F looks like? Same thing.
Just kind of approach. Yeah, and then on this side, it's also. Kind of the same thing. There are nuances. You know, if you plug in a 10 here, output is 1/10, which is very small. And if you plug in a 10 here, the output is 1/100. It's also very, very small, but same behavior.
But this would add the positive, negative. Plus.
Oh, this part? Yeah. Oh, yeah, makes sense. And I hope it makes sense if these are all similar, but exactly the same values in rising. On the left side, in this case. They're squaring a negative. Like in negative 10 here, you get 1/100, the same as you like in it. Nice symmetry about the y-axis. Good question. Let's talk more about some asymptotes, shall we? Yeah, as soon as I find, here it is, page 15. Vertical and horizontal / oblique asymptotes of differential functions. So you're familiar with vertical asymptotes already. They look like vertical lines. So we're going to look at those in just a minute. Oblique, another word for that is symmetric. Yeah, it's amazing. Not necessarily. Yes. Oh, we've been studying ahead.
Hearing whispers in the wind. Oh, okay, it's time back to you now. Okay.
Not involved.
Just make sure that your neighbor knows how to graph this one.
Okay. So we're gonna take the parent graph, which looks like. You need the two hands for this. You gotta cross it over. I see this. And then we move it which direction? To the left. You're. Okay. Now it does say to draw a detailed graph. So the question becomes, how much detail do we want? For 1/x. Y equals 1/x. How many points do I want? I want exactly 2 points. You know which ones they are? Yep, those are the 2 points that I want. And I want to see that. So for right here, that vertical asymptote is now at x equals 2. So what points do I want? Same 2 points, except they move up and over. But I do want one more. If it goes to the two. That's. What's next one that I want? One more. I'm drawing it. What do I want? I heard it. I want the y-axis. Exactly. Intercept. Yeah, it didn't have one before, so I didn't need one. But now that it has one and it's asking for a detailed graph, I want it. Is that difficult? Is that a lot of work? It's not. You're wrong. It's like in zeros, so yeah, zero. Yeah, zero. If it's asking for each. Question. What is asymptotes? That's a very good definition of vertical asymptote. So I'm gonna call it an asymptote a
Guideline for our graph. It's a guideline for our graph. And I'll get into more detail a bit later. So the end behavior, is that difficult end behavior? I think we've seen it already, haven't we? Limit as x approaches. Do you mind if I'm a little bit lazy and do this? Is that confusing if I do that? Plus or minus? As long as it's right and there's no room for confusion. And if I'd have to possibly ask you to come up and explain to me what we've done if I don't understand. So that explanation better be right. Anytime you're making a shortcut. Yeah, I'm saying you can take shortcuts like this, just make sure you're being thoughtful about it. And if I'm confused about what you're saying, I probably will take off points and I may come back and just ask you, hey, can you explain what you're saying here? I'll tell you then why I didn't understand. Oh, it's just be thoughtful. Okay, so describe the end behavior near vertical asymptotes with limit notation. So there we go with the end behavior near the asymptote. We're going to see what happens as x approaches -2 from the left. All right, so I'm just checking. We talked about describing end behavior near vertical asymptote. Okay. I know there's a vertical asymptote when x equals -2, so I want to see what's happening from the left side. So what's happening on the limit of x approaches -2 from the left? -2 from the right. Pause infinity, is that right? I don't know, let's see, this is the graph, I'm pretty sure the graph is right. Okay, I'm approaching -2. Going up, how high is it going up? Super high, as high as you want it to go. Infinity.
So if you had written the one on the top, and you just said, as x approaches 0, then it would be y is positive.
Wait, limit as x approaches, oh, you mean over here? Like for the parent function?
Yeah. Yeah, so you want the top one, so the top one.
Yeah, you'd have to describe it on the left side and the right side. There's two different things. But... Yeah. I put from the left and from the right. Oh, no problem. I understand my writing's not that great. And that's kind of hovering a little bit high. Okay, maybe like that. Now, would it be appropriate to do something like that? Limit as x approaches -2 from the left and right of f of x equals plus or minus. Would that be okay? Just put all that together? That'd be a really terrible judgment call to try to consolidate that. Like, how do I put those pieces together? It just doesn't make any sense. So please be thoughtful and consider the reader. Anytime you're doing work, consider the reader, make it easy to read, and little error or little room for error. So how do you find a vertical asymptote of a rational function? We check with the neighbor and see if they already know. How do you find the vertical asymptote?
So you could have that.
So. Where is the key to finding a vertical asymptote? Where do you find that in the fraction? The denominator. What do you do for the denominator? Set equals. That's it, isn't it? And there you'll find vertical asymptote. Usually, I'm going to put a little caveat. Set denominator. Of the simplified two x plus 2 might think that it's minus. And we're gonna throw this a little bit later. But notice that this simplifies. And now there's no more vertical asymptotes. Removing. But if something cancels,
Cancel it. And then that's where you're going to find your vertical asymptotes. So just make sure it's in the simplified form of the function. How to determine the behavior of a function near its asymptote? Use number line analysis.
try it, man.
Let's try it. It's gonna be a long year. Okay, so number line analysis. Okay, pay attention, please. Now, we are building up to the ability to just graph any rational function. We're building up to that, but we have limited capability. We have limited tools in our toolbox, and that's appropriate. But we have talked about number line and analyzing on a number line. And how many numbers are going to be on this number line? There's going to be two. There's going to be -3 and 1. Should I put a 0 in there just for like reference?
Oh.
Definitely do not do that. It sets up an arbitrary boundary. There should be two boundaries. And just for completion's sake, at this one, I'm going to put the fact that nothing can go there.
Why is -3 then?
Pardon? Because then the denominator. Now at that -3 actually is a 0. If I plug in -3, isn't the result equal to 0?
Yeah.
I'm gonna put a solid dot there. And maybe I'll start even building my toolbox here. Like I know there's a vertical asymptote there at 1. How do I know that? Because the denominator equal to 0. There's a vertical asymptote at 1. Now I just want to figure out, is it above it or below it? Is it positive or is it negative? So what should I do?
Plug in a positive number.
Plug in,
Probably 1. No, not 1.
right, right.
Negative
And then start over up here on this side.
2.
2. Okay, I'll plug in 2. I see I have positive or positive. Which means if this is a vertical asymptote, you see what's about to happen?
Positive.
It's gonna go up like this. Now, we don't have enough to say exactly where it's gonna end, like for end behavior. But I'm just gonna kind of do this. Okay, I don't care about the other side because right now we're just analyzing the vertical asymptotes, right? Describe the behavior near the vertical asymptote. Now I know that 1 has a multiplicity of 1, and so does -3.
How does 1 have a multiplicity of 1? How do you do it?
Because if it said something like this, then it would have multiplicity too. Right, there's only one of those factors, so it's it relates to what we did with polynomials. We can still talk about multiplicity, even though it's a rational function. So I don't even have to test any more points. I see this is positive. And here it's going to be negative, and here it's going to be positive again. And I didn't care about what's going on in the graph, just care about the asymptote. So it goes from positive to negative. Do you see what it's going to look like? This. So I'm going to graph a little bit more just for fun because I don't have to take out a whole lot more information. But I'm just going to kind of do this. And I know it goes through that 3 because it's an interceptor. Plug in the 3, you get a 0. Okay, it goes out there. That's what's practical. Okay, let's finish this one and I'll give you a chance to interface with one another. Describe the behavior near the vertical asymptotes from both directions. Is this enough for a description? No. It's a really good visualization, but when you say describe, you mean use specifically limit notation. Would you please go ahead and write the behavior near the vertical asymptote? Check with your neighbor when you.
So would also allow for the like one plus minus on either side.
They're two different answers, so.
But it's like if they were the same answer.
I can see that.
Would be a viable for a time.
Oh, if it's the same from both sides, you don't have to put either one. Just put to one.
Huh.
Baron, always with the great questions. Yes. In my number line analysis, I was just doing. Oops, that's a 1. Okay, you're wrong. Oh, I did wrong. I did wrong. Thank you. Good catch. Okay, did you get it right? This is all I care about. Left side was 1 and right side was 1. Left side was negative thing. Okay. Right side was positive thing. You have all the little pieces where it belongs. Now we're going to talk about number line analysis. I was going to do this very quickly, just switch to positive, and we have a vertical asymptote. I put those pieces together right there, and I knew everything's multiplicity 1 and then positive and negative. As long as one of them is right, the rest of them will be correct. But we mentioned the initial calculation is appropriate. Does that make sense? Yes. So what we're doing is like you write out one? Write out the whole number. Because you want to actually do does that make sense? Right, little calculations like that. Like this is the word, plus minus plus, or the positive, negative, positive. That is the word. You know, to show how you got it now. But if I ask you and you don't know, then we have a problem. Yes.
If there honestly some first initial calculation, I'll leave it as if without right based off the wrong calculation, so you get those still, but it's partial for me.
Absolutely. Okay. And if I miss it, let me know. Because you're right. If one little, especially arithmetic, if the arithmetic is wrong and the rest of the problem get like marked up crazily, then there's an issue with that. And it's doesn't seem fair to me. Yes, me too.
The graph itself.
whatever you need to do to get it correct, because the right answer is here, the limit problem. So I think this is not here. Okay. Well, whatever, it's up to you. I give you tools, you use them appropriately, so thank you for deciphering. Yes.
You now have to write the limit of f of x as x approaches positive and negative infinity. Is that not something that we have to?
Right, if it's asking for and B, so that's what I'm looking for. Okay. Will you please try this one? But first of all, discuss with your neighbor, what's gonna happen on your number line?
I think you're looking at really negative. So that. And that's so.
How many limit statements are you gonna write?
What?
Write 4 limit statements?
Oh, yeah, we missed that. But you can't have minus proof, like, the 5i.
No, that's when it's, yeah, like, this one outside, I just. Yeah.
I have no idea.
Getting something? I'll take that again. Okay, folks. Did you get it?
Yeah.
10 seconds.
I don't know.
Okay, everybody, let's do this. How many places are on the number line? We're gonna mark 3. Negative, not 5, negative root 5, right? Root 5. Should I put a 0 here?
Yeah.
Is it important?
Yeah.
Why?
Zero.
It's a 0. At the numerator. It makes it a 0. It's definitely important. Should I put in like because we know square root of 5 is in between what 2 numbers? Should I put in the 2 and 3 just so we all know? No, don't put extra information, please. I beg of you. No extra information on the number line. Okay, now what? 3, okay. And 3 falls where?
Or 9.
Should we do this? Did you do this quickly? And then at 0, we have, you do this. Right. Well, yeah, so either open circle or square. keep in mind that there's not never we're about to do. So when you plug in 3, you got what, 3 over positive, I think it's positive, so. You did this. Does anything have a multiplicity of 2 here?
Zero.
Does 0 have a multiplicity too?
It's the.
If it said x squared, that'd be a multiplicity of 2. It's just x. The bottom, if I were to factor this, wouldn't it be x minus root 5 and x plus root 5? Yeah, they're both multiplicity 1, right? We don't have a factor that's being squared.
X plus 4.
Now, what?
X squared plus 4.
What's X squared in the middle?
Plus 4.
No, wait.
If it were something like x plus 4 squared, then we'd have a multiplicity
So,
2.
so what does it look like in the middle?
It looks like, well, it's got to come from here, right? All we care about is end behavior or the behavior near that, but it goes through this 0. Doesn't it? Well, remember, we have plus, minus,
Well,
plus.
like,
Yes. Yeah. It's gonna go up like this. Right, we're already kind of graphing this.
It's like a tangent, right? Like
It's kind of like tangent. isn't it?
yeah.
Good point. Over here, do we know what it looks like? Do we plug in the point, what's the negative?
No, we don't know.
We don't need to. Yeah, don't do extra work. You can. It's not gonna hurt except take more time. So we know that it was up there, now it's gonna be down there.
I don't like the way that comes.
Not in front of that thing. That's
No,
just
it's
mean.
No. No, it's.
What you, so many,
No,
so much
that-
hate. Okay, I'm just gonna do one of these. Let's do limit as x approaches. Which one do you want to do? The square root, positive square root of 5. Okay, square root of 5 from the left is equal to negative infinity. Limit as x equals square root of 5 from the right of this function is equal to. Did I write those correctly? I'm going to say 2 more here because I don't want to spend more time on this. But I will say, some of you on your quiz will omit the alphabet.
Can you write on the Y?
You can put what? You'll omit anything there. But that's like saying, what's the square root of? You need an of, you need something in there. Same thing with the limit. So limit of a function. You could put this entire function here if you want. Yeah, you have options, f of x, y, or the entire function. Just don't leave it blank. If you leave it blank, I promise I will take off 1 point. And if you leave off all of the f of x's, it'll just be 1 point. So I'm not gonna just do that to you every single time.
So this, if I did it on 2 different questions.
I won't take off multiple times for the same notational error. And Ella, actually, you asked something about earlier about what if you just make a calculation error. I do have to be clear, only 1 point is 1 point off. That's the minimum I could think of for any time. I don't take off that one, so I take off 1 point. The calculation error in calculation. But if that error made the problem easier, like change the whole flavor of the problem, then I have to take off 1 point.
Wait.
Like if you did so, I don't know, if you did something like this, suddenly it's crazy easy problem 1 over x minus 5. You can say, well, I just divided wrong, but you're missing an asymptote here. You've done some bad calculations. So if it's a simple arithmetic error that doesn't completely change the flavor of the problem, only 1 point after that. Moving on. Oh, but before we do, I'm gonna give you time to either discuss or zone out until 34.
Oh.
Oh my gosh, I'm sorry I'm late. Okay, folks. Let's do this. You ready to finish this off? Horizontal or oblique asymptotes. Okay. Karen, you're gonna love it.
I guarantee. The sideways one.
Let's talk about attitude for just a moment.
Okay.
Whether you think you can or you think you can't,
The answer is
you're right.
but
Have you heard that before? If you think you can or you think you can't, you're right. Like inspirational. You think you're gonna love it? You think you're not gonna love it? You're right. But I'm pretty sure you're gonna, seriously, you are gonna adore it. You're gonna be like,
Tell me how to do that.
oh yeah,
Like, you have to understand what you're doing.
yeah. Understanding is the key. Yes. Okay, folks. Enough of the philosophy there. Let's do some math, shall we? There are three cases. Now, rational function means we're dealing with a function that has two parts, right? It has a numerator and denominator. So those are the only things really that have these oblique asymptotes. What's another word for oblique? Slant. I could handle diagonal too. But case one is, I'm going to call it bottom heavy. Now that's a phrase that's very common at this school. And what does it mean for it to be bottom heavy? Just
It means that the exponent, on the denominator, is not a numerator.
perfect. Are we good with that? Every class had different things. Yeah, so it's a fraction, and it's talking about the degrees of the top and the bottom, the degrees. So if the bottom is a higher degree, like Josephine said, then it's considered bottom heavy. Yeah, so if it's bottom heavy, then it has a horizontal asymptote. Horizontal asymptote, which I will never spell out again. Instead, I'm just gonna call it HA of y equals 0. I'm gonna talk about why that is just a moment. Could you show me y equals 0? Just in front of you, what does y equals 0 look like? Okay, it is the x-axis, y equals 0. That's case 1. Case 2, what do you think this case 2 is? Yeah, top heavy. Top heavy. By 1. Just by 1. That's the only case that this class really covers. Right? So it could be like 100th degree on top and 3rd degree on the bottom. We're not going to talk about that. By 1 just means that the 5th degree on the top, we're going to be looking at 4th degree on the bottom. What's that? It does have, it has an asymptote, but this one has an oblique asymptote. Yes. And I'm never going to spell out oblique asymptote again. OA is the quotient. And again, we're going to go over examples for all 3 cases because there are 3. There's one more coming. The quotient of the function. Remember, it's a rational function. Don't include the remainder. And I promise I'll talk about it. Don't include remainder. And case 3. What do you think case 3 is? Even. I'm going to call it balanced, but even makes perfect sense. It has a horizontal asymptote. Y equals ratio of what coefficients? Leading coefficients, yeah. Yes, what's this sneezer? Okay, so if it's bottom heavy, it's horizontal asymptote is always y equals 0. If it's top heavy, by 1, add oblique asymptote, and you get that by using division. And if it's even or balanced, then it's a ratio of the leading coefficients. And we'll do one of each. Oh, I gave you more than one, but we're just going to do more than one. And we're just going to do one each. Okay, so this one we say, hey, it's a rational function. Now, am I looking for vertical asymptotes here?
No.
I'm not. I'm looking for either horizontal or oblique asymptotes. And we notice that this expression is bottom heavy, isn't it?
Yeah.
So all we care about is that it's bottom heavy. We already know that it has a horizontal asymptote, y equals 0. Always y equals 0. So why is that? You want to know why it is, or just want to know what that it is? Okay, but horizontal asymptote comes from, well, we don't care what's going on in the middle. Right? There may be some vertical asymptotes or something. We care about what's going on over here and over here. Does that make sense? It would look like that for horizontal asymptotes?
Right.
So as x approaches infinity, apparently it's going to 0. If we got negative. Let's plug in a huge number, like, I don't know, 100. You plug in 100 here, I hope it makes sense. One of the 3 you can make some great. Okay. In fact, the only thing that has any real power is this. Plug in 100 into the cubic compared to the 100.
The bottom is such a big number, and the top, you go this big.
There it is. There it is. Perfect. Since the bottom is growing at such a huge rate compared to the top, the value goes to 0. But again, when you plug in 100, I'm talking about what is 100 to a million? What, 100 to the 7? Yeah. That's huge already, and that's just plugging in 100. We're going to infinity. So the bottom just overpowers the rest. Over here, overpowers the rest of that. We're not talking about what happens in the middle.
In the world is actually where it's like the bottom is like X, and then the top is like a bunch of X there.
Like enough to overpower cubes? Only temporarily. Because that becomes like x squared plus x squared plus x was like 5x squared. Maybe it becomes multiplying times some constant. As opposed to multiplying by 1,000 and then 1,000,000. Always great questions. Yeah, don't hold back any questions, folks. Yes, speak. No. Well, not yet, not yet.
By not yet, do you mean like?
Like maybe next time, actually. And it's not bad yet. Hey, you're gonna love it.
The meeting with.
You're gonna love it.
Oh. That was the fun thing.
This is so cute. So cute in your fear.
And that was the fun.
Wait, let me see. So do I have to describe end behavior using limit notation? Is that difficult now?
Oh,
Limit as x goes to positive infinity.
0.
And we can put it together, can't we?
Yeah.
Single one, positive negative infinity is equal. Do you mind if I skip that?
No, that's fine.
Thank you. This one we notice, hey, it's rational and
Balance.
it's balanced. Therefore, it has
An oblique. Oh, wait, no.
it has a horizontal asymptote, which is y equals. Should I say 2/-6? No, don't leave it like that. -1/3. That is the horizontal asymptote. We found it. Yay. Okay. And I'm gonna kind of talk about this in the same way. We plug in huge numbers. Like we're plugging in 1,000 here. I hope you know, there's some. There's 5 in the water and so it becomes different. Actually, very quickly becomes different. These also become leaving 2x squared over negative x squared, and then x squared. Also, so we plug in 1,000 here, 1,000 here. Those thousands are the same magnitude. So if we're approaching -1/3, no matter how big we get, we're gonna have that ratio, the leading coefficients
But
winning.
one of the, you could get to a third because of the cost of their mining.
It could get to a third.
So it's not.
And let's talk about it in a minute. So graphically speaking, what's happening? We have this horizontal asymptote at -1/3, -1/3. And ultimately we know that I have no idea what it looks in the middle, but it's gonna do something like this, and it might be above, it might be below. I don't know.
So it's the same limit. So
It's the same though. It's in this case, it is a little bit different. Could you please write the limit statements appropriately? And please don't copy the answer, but write the limit statements. You know, necessary combined and appropriate name. And behavior. Right, this is saying I describe the end behavior using limit notation. Check with your neighbor, make sure they did it right. So as x approaches negative infinity of this function, the limit is equal to -1/3.
yeah, the same thing.
Same thing with the positive one. I guess I could put both of those together. Now, if I want to find vertical asymptotes, what would I have to do? I have to set the denominator of the simplified form equal to 0. That's why I'm not going to ask that. This is crazy. I don't know if it's factored. Yeah. Not really. Sorry. It's coming soon though. Look at all the excitement. The anticipation. Yeah. Hey, look at this one. It's rational and top heavy by 1. Therefore, it has oblique asymptote. Okay, so oblique asymptote. How am I going to figure out what that is?
You're gonna do something with relation.
I'm going to find the quotient, which means I have to divide. How shall I divide this? Synthetic division. Wouldn't that be nice? There you go.
I.
I think the one goes here, then one, one, two.
What's the, you know, it's a one because there's X minus one.
Yeah,
Put the opposite, so it's in the box.
yeah. It's just a procedure. It is synthetic. Would you just finish it, check with your neighbor, make sure they know what the answer is? Oh, I'm sorry, I should move that.
Like it's not.
Like, it's not what?
One bring down, one time one. One, one, two, two times one, two, four.
Did we get this? Okay, so does it make sense that this is equal to X plus two? Are we good with this? This is equivalent? No. So the X plus two, I think, right here, I'm counting these, moving forward, put that four over the original. Minus one. Right, so the oblique asymptote is Y equals X plus two, that's it.
So why are we ignoring your?
Good question. Because I said so. Well, remember what's happening. We're taking the limits as X goes to infinity. What happens with little piece as X goes to infinity? Right, it's becoming zero, doesn't it? Insignificant, as opposed to this, right? This is huge. Like if I plug in 1,000 right here, we have 1,002. Plus 4. 999. Almost nothing. Okay, like this becomes less significant.
Okay, so, okay, sure.
Let's talk about a tool that I hope you all know and truly love. There's one.
I love those modes, I definitely.
Please pick out your laptop if you have it.
What do you think about that?
Wait, what's that? Did you bookmark it as well? Bookmark it, yeah, grab it back. I don't, it's such a good. Oh, yeah. Oh, we're not gonna copy and paste anything. We're not done with notes though. Yeah, keep your notes out. What are we about to type in? What do you think we're about to type in? Yeah, I'm excited. That's good. Sense? So how close is it? Close. You see it? Like you have it on your best list to do it. What's the second thing you'd like to try? X. What was it? What's the one? Now should I do the remainder too? Plus 4 over X minus 1.
Oh, wait, they're the same thing. They're not the slant asymptote is just a quotient. It's just a quotient. And it's just the, oh, that's so. But wrong. Let's plug in one more thing. What else do I want to plug in here? The last book, which should happen at x equals 1. Is it x equals
Something.
Yeah.
Look at that.
The green line.
Yeah. We can change the color. We don't like that color. So there you see it. A oblique asymptote, our very first, perhaps. Any questions? Okay, let's go back to the packet. I just really wanted to see that approaching behavior. Okay, now the question was asking for describe the end behavior using limit notation. Okay.
We have to like find out where about the like where is the word about for at what point.
is as you desire, and the answer is yes. Of course.
Anything meets. Okay, so this is what it looks like. We're going to say the limit as x approaches. We're talking about infinity and negative infinity here. X approaches negative infinity of this function. So for infinity, this approaches. No, I'll let you finish discussing it later.
I mean, I guess. Why go
So as x approaches infinity, what's happening to the y? Infinity, right? You can see that on the graph. Going up. And as x approaches negative infinity? Now, do we actually need to see the graph, or is just knowing the equation of the oblique asymptote enough to tell us where it's going?
So.
Yeah, I think you know what this line looks like.
Yeah.
It's following that line. It's the same behavior as that line. Yeah. But this would have been negative slope.
But you don't know if it.
It could be above or below. It could have been like here.
Yeah, oh, but I guess that it's still. It's the same.
Yeah, it's the same concept. Okay. Any questions? Is this terrible, or are you doing okay with it? Okay. I got some two thumbs up.
I'm somewhere in.
It seems like you've been hurt in math. Yeah. Well, I'm not here to hurt you. I'm here to make you feel good with some good math. No, this year, you're gonna love it. You're gonna love it. Nope, not forever, not room forever. Let's see. Okay. Oh, this looks like something fun for you to do for like tonight. Your homework tonight. So yeah, your homework should go until 18. Yeah, you don't have, definitely 18 is where we're stopping for that. And I just want to go back to page 3 really quickly. Way back in time to like last week. I just forgot if I talked to you, like I heard someone talking about restricted values. Did we talk about restricted values? I feel like I may have forgotten. We did talk about them?
Denominator 0.
Okay.
Where negative.
Okay. I was just thinking crap. I can't
And then you have the.
Okay, and so.
And then you kind of go.
Yeah, like here, if I'm looking for excluded values, I would say X can't equal 0 and -3. Oh, that's so interesting, but for instance, you said, and also Y can't equal 0. That would be the restriction. So today, what are the salient points? What do you need to take with you? What kind of asymptotes? Horizontal, vertical, and oblique asymptotes. Oblique asymptotes happen when
Top heavy by one.
top heavy by 1. It's horizontal asymptote is 0 when bottom heavy, and then what's that last one? With even. It's the ratio of the. I feel like you could teach this already. I feel like you guys.
I can't be. I think but
I think you can. Okay, folks, I got nothing else for you. We're a little bit early, so please, in case you like, please just be silent in the hallway. Have a wonderful day. My pleasure. My pleasure. My pleasure.